Hey, Mr. Godfrey here. This is Chapter P, Prerequisite Chapter for Pre-Calculus, Lesson 5, and we're looking at ways to solve quadratic equations. And remember, there's 4 ways to solve a quadratic equation: factoring, extracting the square root, completing the square, and then quadratic formula. And then if you add in using a calculator or graphing, that's a 5th way to solve a quadratic. In this video, we're going to look at extracting the square roots. And there's 2 types of problems that when you see them, you'll want to think to do this. Okay, we covered a lesson on factoring where the leading coefficient was not a 1. That was a previous video. There's 2 cases you want to look for here. The first one is where there is no bx term. And again, when I'm talking about a bx term, as a reminder, we're talking about the standard form of a quadratic is ax squared plus bx plus c. In this scenario, there is no bx term. So all you're going to have is a squared term and a constant. That's all you're going to have. So whenever you have this scenario, you don't want to factor. That's a long way to go. You may use factoring as part of the process, but really you're not going to want to use factoring. You want to do what we call extracting the square root. The other scenario is still the same thing. There's no bx term, but you're going to see something like this: x plus 3 squared is equal to 7. And in this case, you don't want to multiply these together. Some students multiply that together and then end up then you go to factoring and you end up right back where you started from, so because that's what factoring does. It undoes your multiplying. So in this case, I'll show you how to do that. It's really easy. It's pretty much set up for you. All you want to do there is take the square root. Alright, so those are the 2 scenarios that you're going to look at when there's no bx term or when it looks like that other way. Now, you're going to use the properties of equality to solve, and here's a very key point. Because you're going to be taking the square root at the end, that's always going to produce 2 answers, a plus or minus. And if you remember from last year, quadratics, 2 terms, or it's a second degree polynomial, which means it's going to have 2 solutions. So it's always going to get a plus or minus when you take the square root. So remember that rule. When you're taking the square root as a part of solving an equation, you have to take the plus or minus when you do that. Okay, so here's the scenario that I said before. It's already set up here. You don't want to multiply it out. All you have to do here is take the square root of both sides. If I take the square root of both sides, that's going to give me 2x minus 1. It's going to take away the square on this side. And notice I took plus or minus 3, because positive 3 times positive 3 is 9, and negative 3 times negative 3 is also 9. Then we go ahead and add 1 to both sides, or we can split it into 2 equations. 2x minus 1 is equal to positive 3, and 2x minus 1 is equal to negative 3. So this is creating our 2 equations which we solve. So x can either be 2 or x can be equal to negative 1. Okay, so whenever there's no bx term or it's in this form, you simply get the squared term by itself, take the square root, and then solve from there, making sure you take plus or minus. So let's do an example or 2. Whoa, I've got those all set up here. Let's do it this way. So some examples here. Let's take this first one. 2x plus 3 squared is equal to negative 169. So it's already set up for me where this is by itself. So I'm going to take the square root of both sides. Okay, and this is going to be 2x plus 3. And because I took the square root over here, it's going to be plus or minus. Before that's going to be 2x plus 2x plus 3 equals positive 13, or 2x plus 3 is equal to negative 13, and then I can go ahead and solve both of those equations. So 2x is equal to 10, so x is equal to 5 would be one of my answers. And then I have 2x is equal to negative 16, so x is equal to negative 8. So my 2 answers would be either 5 or negative 8. 5 or negative 8. Okay, let's go ahead and do one more example. So let's do an example that's a little bit more complicated. And in this case, there's a 3 times this. Now, you cannot take the square root of this right now because the 3 is not being squared. So that's going to make that end up being underneath the square root on this side, which we don't want. So what you have to do first is divide by 3. And you have to kind of remember this rule, that whenever you're trying to solve a quadratic and you're using extracting the square roots, the square root term has to be by itself before you can actually take the square root to unsquare it. So that's going to give me this. So now that this is by itself, I can take the square root. So that's going to give me x plus 4, taking the square root of this side, equals, and then plus or minus the square root of 8 over 3. Now don't panic here, and don't be using your calculator to find out the decimal approximation of that. You don't need to do that. Just simplify as far as you can without going any further. So I need to solve for x, so I'm going to subtract 4, so x is equal to negative 4 plus or minus the square root of 8 over 3. Okay, and that would be pretty much okay, except that we can go ahead and rationalize this square root here, but I don't think they do in the answer, so we'll just stop there. But that would be what that would equal. So that would be equal negative 4 plus or minus the square root of 8 over 3. So don't be turning this into a decimal. You don't need to. This answer, just like this, is just fine. Okay, a decimal answer doesn't do us any good beyond what we're doing. So let's do one more example. A very easy example. The x squared term is by itself, so you want to take the square root of both sides. 2x is equal to plus or minus 5. That's where you got to be careful. So x is going to be equal to plus or minus 5 halves. So again, we're going to produce two answers. Okay, so that's how you would solve a quadratic by extracting the square root.